Hello and welcome to my all of Year 9 Maths video. So I'm very proud to have released this. This is based on the White Rose Maths scheme of learning. So you'll see that right in front of you now, and it goes through all the major topics you need to know to do really well in those Year 9 end of year exams, or generally in your half-term assessments throughout the year as well. Notice that some topics may be missing from what you cover in your specific school. So if you cover trigonometry, for example, then of course check out the video just above, but you'll notice there might be some topics that are missing. So this goes through a vast majority of the topics, again follows the White Rose scheme of learning, so it should be a majority of what you need to cover to do really well on your end of year exams.
Okay, so let's look at straight line graphs, a very important topic on the Year 9 Maths course. So question 1, we have two straight lines, L1 here and L2 are shown on the grid. And first of all, we need to write down the coordinates, that's important, of the point where L1 and L2 meet. So notice where these lines cross is at this point here. And remember, we go along the corridor. So we go along the corridor to -3, and then we go up or down the stairs. In this case, we're going to go up the stairs, and that gets us to 2. So when we write this as a coordinate, we go -3 along the corridor, and then up the stairs up to 2. So remember, when we do a coordinate here, we need to include those brackets and the comma in between the x coordinate, which is -3, and up to 2. And now we need to write down the equations of the lines. And my students struggle with this. So the way I represent this is as follows. Let's just choose some random coordinates on here. So this coordinate here, for example, is going to be 2, 2. And we take this coordinate, that's going to be 4, 2, like so. And now we look at all these three coordinates. What do they have in common? So let me get the old highlighter out, the trusty highlighter. So this here, this here, this here. What do they have in common? Well, all the y coordinates are equal to 2. Therefore, we write down y equals 2. So any horizontal line gives you an equation of y equals. Now we can do the same idea with L2 here as well. So let's take some random coordinates. So we have -3, -2. And we go up the top, let's go up here. So it's going to be -3 and 5. And when we look at all these coordinates, what do they all have in common? Well, notice the x coordinate is equal to -3. So what we write down is x is equal to -3. We're looking for what's in common with all the points on the particular line. Now let's move on to question 2. So complete the table of values for y equals 3x plus 2. I use a nice little sneaky trick here to work this out. First of all, always start with the positive numbers. It will make your life easier. So let's have a look at when x is equal to 2, because then we can work out what goes in below. So I'm going to copy this out, and wherever I see an x, I'm going to put a 2, because we're looking at this one. So 3 lots of 2 plus 2. And at this stage, we can just work this out using BIDMAS. So we do the multiplying first. 3 times 2 is equal to 6. 6 plus 2 is equal to 8. So 8 will go in here. And we can do exactly the same idea here, but instead use x is 1. So let's now focus on x being 1. So I'm going to copy this out. Wherever I see an x, I'm going to put a 1. So we get y equals 3 lots of 1 plus 2, and that's equal to, well, 1 times 3 is 3, 3 plus 2 is equal to 5. So let's pop in 5 there. Now when x is equal to 0, that's a nice one for us, because 3 times 0 is equal to 0, and so we're just left with the y-intercept of 2. And once you have this, we don't even need to work with negative numbers here. We look at the sequence. So notice this is going down in threes. 8 minus 3 is 5. 5 minus 3 is equal to 2. So all we need to do is keep subtracting 3 each time. So 2 minus 3, so it's 2 degrees, it gets 3 degrees colder, so that's going to be -1 degrees. And then it's -1 degrees, it gets 3 degrees colder, that's going to give us -4. And the second part of the question just wants us to turn this into coordinates. So notice we've got 2, 8. So what it wants us to do here is just plot 2, 8, 1, 5, 0, 2, and so on. So remember what we did over in question 1. So we want to go along the corridor, so 2, up the stairs, that's equal to 8. Along the corridor, so that's 1, up the stairs to 5. Along the corridor, so that's 0, and up to 2. Along the corridor, minus 1, and then down to minus 1. And then along the corridor, and then down to minus 4. And if you've done this correctly, you should always get a straight line. If there's not a straight line, then you haven't done this correctly, because there's no x squareds or x cubes or something weird. At this point, it will want you to join up the line. So I don't have a ruler here, so I'm going to do this best freehand. You should use a ruler at home. So we're going to draw a line. It's not too bad, not too bad. Yeah, that's not too bad at all. So just make sure once you've plotted those coordinates that we've outlined from the table, that you put that onto the graph with a clear straight line. Now on to question 3. So you want to write down the gradient of each line segment. So the first thing I like to do is going from left to right, is it going upwards or downwards? So from left to right, this is going downwards, whereas this from left to right, this is going upwards. So this answer is going to be negative because we're going downwards, and this one's going to be positive, which means going upwards. Now the way we work out the gradient is that classic rise over run. So rise divided by run. Now what do I mean by this? Well, the rise is the height of this right angle triangle that's been made for us. So let me just indicate that that's our rise. And then the run is the horizontal length at the bottom. So this is our run. And all we do is just do rise divided by run. So let's count how many squares is the rise. Well, 1, 2, 3. So put 3 at the top of our fraction. And how much at the bottom? Well, that's going to be 1, 2, 3 as well. And of course, we can simplify this fraction because 3 divided by 3 is equal to 1. So our answer will be minus 1. And we do this in exactly the same way. Just make sure you get your rise and runs the right way round. So the rise here, well, that's going to be 1 square. And the run, that's going to be the bottom part. So 1, 2, 3. So this one gives us plus a third. And generally with gradients, we want to make sure that we leave it as a fraction. So our two answers here are minus 1 and then positive a third. Okay, on to the next questions. So which of these graphs will go through the point 0, 4 and circle your answers? So the way I do this, I just pretend to myself that x is equal to 0 and I want to get the answer y equals 4. Remember, the first number is the x coordinate and the second is the y coordinate. So if I do that here with this one, well, when x is 0, well, that gives me 4 times 0. That's equal to 0. I wanted 4, so that doesn't work. Remember, we need to circle the correct answers. Here, when x is equal to 0, well, that gives us then 0 plus 4. That's equal to 4. So that's correct. That's a good one. So make sure we circle it. Always follow the instructions you're given in the question. Here, well, x is 0, so y equals 4 minus 0. And that's equal to 4, so that's also good. And with these questions, you do have to check everything. So here, when x is 0, we get 0 minus 4, which is equal to minus 4. Okay, we don't want that. And here we get 0 divided by 4, which is equal to 0. And also we don't want that either. So there's only two answers here that are correct. Y equals x plus 4 and y equals 4 minus x. Now on to question 5. They're being a little bit tricky here. They want to write down the gradient and the coordinates of the y-intercept on this particular line. Now you probably haven't seen it written like this, so I'm going to do a little bit of a change. Generally when we write it in the form of y equals mx plus c, so this is the general form that we use, this stands for our gradient and this stands for the y-intercept. So what I'm going to do is flip this around, which I'm allowed to do. So I'm going to bring the minus 2x to the front and the plus 7, because notice just 7 on its own, so it's a plus 7, like so. Now the gradient is always the number in front of the x, like so. So the gradient here is going to be equal to minus 2. Now the y-intercept, be careful because they want the coordinates of it as well. So we can't just write 7 here. What we need to do is write the coordinates, which is 0, 7, because we want to know where it crosses the y-axis, and the x value has to be 0 at that particular point. You could do that also by substituting x is 0 in here and giving you y equals 7. Okay, now we're going to combine a lot of what we already looked at here into question 6, working out the equation of the line. So there's a two-step procedure here. First, we need to work out the gradient, which we did in question 3 before, and then 2, the y-intercept, which is usually the easiest part, and then we're going to combine that together. Now, a lot of questions that students ask me here is, how big do I draw my triangle? And my answer to that is, well, make sure you get whole number values. So when I draw my triangle to work out the gradient, notice I'm going to take points where it actually hits the corner of the boxes. Okay, so that's how I've decided where to draw my triangle. I could make it much bigger, could make it a bit smaller, but I'm going to go with this one in particular. This triangle needs to be a right angle. Now remember that formula from the previous slide, rise over run. So we're going to use that again. So the rise here is equal to 1, 2, 3, 4. The run here is equal to 1, 2. Now because we're going from left to right upwards, it's going to be a positive gradient. So let me just write the gradient here. So gradient, it's going to be a plus. So it's going to be plus, well, rise is 4, the run is 2, and 4 divided by 2 is just equal to 2. So we've done our first part here, worked out the gradient. Now the y-intercept is the easiest thing to work out here, so that's where it crosses the y-axis. And notice it crosses the y-axis at -1. So the y-intercept will be equal to -1. And now we use this formula from before. So y equals, the gradient is equal to 2, so we're going to put a 2 in front of the x, and then plus c, well, our y-intercept is -1, so we just then put -1, like so. And on to the more application style questions here. So this is question 7. So Sammy earns £4,000 a month. She spends X pounds and Y pounds as shown on the graph. How much does she save when she spends £1,200? So we want to work out when they spend £1,200. So we want to look at the x-axis, the amount spent. Now we want 1,200, so we need to look at the scale very carefully here. Well, I think this goes up in 200s. Notice there's 5 gaps. There's 1,000, so each one little square will be 200. So 1,000, 1,200. And then we do a dotted line upwards. Much easier if you've got the sheet in front of you. But I'll do as accurate as possible. And then we come across here. Notice this scale is the same. You should always check that both scales are working in the same way. That's going to give us 2,200, 400, 600, 2,800. And now we need to put this in pounds. So 2,800, like so. And now we need to work out the equation of the line. So we do this in exactly the same way as how we did question 6. So I'm going to draw a triangle. Again, it can be big, it can be small, but as long as we draw a right angle triangle and make sure it's nice and accurate. Now notice this is a downward sloping, so our gradient here is going to be negative, whatever number that is. And I go back to my rise over run. So our rise here is going to be 1,000. Our run here is also going to be 1,000, and 1,000 divided by 1,000, that's equal to 1. So our gradient will be -1. Next thing we need to do is work out the y-intercept, so where it crosses the y-axis, and that's straightforward for us because it just crosses here up at 4,000, so that's nice and straightforward. And now we've got everything we need to work out the equation of the line. So y equals, that's how we always start, mx plus c, so m here is equal to -1. Let's go -1x or just -x, and then our y-intercept is 4,000, so plus 4,000, like so. And this, a slightly more trickier question at the end here. The table shows how long it takes to empty a water tank using different number of pumps. And first of all, we need to complete the table. So the first thing I do when I look at this table is like, okay, this is going upwards and this is going downwards. What's going on here? But then I notice the link between these numbers. Notice that 10 times 6 is equal to 60. 2 times 30 is equal to 60. 1 times 60 is equal to 60. So I want to put numbers in here such that when I multiply it with the number above, I always get 60. So something times 3 is 60. Well, that has to be 20. Something times 4 is equal to 60. That's 15. And then something times 5 is equal to 60. Know your 12 times table, always helpful. And that gives you 12. So you get 2 marks just for filling in the table correctly. And then describe the relationship between number of pumps used and time taken. Now usually I'd use words like inverse proportion, but the mark scheme doesn't want that, so we just need to be much more straightforward. So as number of pumps increase, time taken decreases. So just writing very clearly exactly what relationship is going on here. So as number of pumps increase, time taken decreases. Okay, so you can check the answers here, so what I've written down and how they've actually awarded the marks as well, which is always interesting to see. Okay, if you're liking this content and this is the kind of content that you want, then please do like and subscribe. Liking being the most important thing, and you can share it to as many Year 9 students out there as possible. Okay, on to equation solving, a really important skill, particularly when you're going to iGCSE, GCSE and beyond. So we need to solve the following equations. Now I always tend to use my arrow approach and use what we call inverse operations. Let's see this in action. So a plus 24 is equal to 39, and we need to work out what this missing value is called a. So what's the opposite of plus 24? Well, we want to minus 24 from both sides. The reason we do this is this 24 minus 24 cancels, which is exactly what we want. So we're left with just a. We have to do the same to both sides. It's like a scale. So 39 minus 24, well, that's going to be equal to 15. You can always do this by actually writing out the calculation as well. And this works in exactly the same way. Again, we're focusing on getting the b on its own to solve the equation. So we look at what's next to the minus 24. So what's the opposite of minus 24? Well, that's plus 24 on both sides. And if we do that process, well, this cancels. That's exactly what we wanted, b on its own. And then 39 plus 24. So mental maths here. So 39 plus 20 is equal to 59. 59 plus 4 is equal to 63. And whether we write 63 equals b or the other way around, that is still the same equivalent answer. Now, a lot of questions here go into 2-step or 3-step, and this is no different. So again, we focus on getting that c on its own here. First thing that we do is we look at that minus 10 and we say to ourselves, there we are. What's the opposite of minus 10? Well, we're going to add 10 on both sides. This cancels, so we're left with 4c, which we'll deal with in a moment. And then 26 plus 10 is equal to 36. But we want c on its own here, not 4c. So what's the opposite of 4 times c? So what's the opposite of multiplying? Well, we want to divide by 4 on both sides. Some people call this reverse BIDMAS. 4 divided by 4 is 1. That cancels. Exactly what we wanted. And then 36 divided by 4 is equal to 9. So 9 is going to be our answer. And again, this works in a similar way to what we've looked at before. So we've got a big divide sign here. That's kind of annoying. We want d on its own. So what's the opposite of dividing by 4? Well, we want to times by 4 on both sides. This has the lovely benefit of cancelling, leaving us just with the numerator here of d minus 3. But don't forget to times 4 on the other side. So 11 times 4 is equal to 44. And now we do very similar to what we did in the first question. The minus 3 is annoying. What's the opposite of minus 3? Well, plus 3 on both sides. This cancels. We're left with d is equal to 47. We write in here. Notice for these slightly more complicated questions, we do pick up an extra method mark in there. Now Dora has solved this equation, at least she thinks she solved it by working through this process. She's incorrect and we need to explain her mistake. So let's look at the first part here. Well, she's expanded the brackets, so 3 times x is 3x, 3 times 2 is equal to, 3 times 2 is equal to 6. This is the problem here. This should be a plus 6. So incorrect expansion of brackets, and I have already indicated what the mistake is, so plus 6, not plus 5. And so from that point I'm actually going to solve it, so I'm just going to replace the 5 with a 6, and now I'm going to use exactly the same process that I did over here on the left hand side. So the plus 6 is annoying. What's the opposite of plus 6? Well, minus 6 on both sides. This cancels, leaving us 3x is equal to 62 minus 6. So that's going to give us 56. And now we still do the same process we did before. The times by 3 is annoying. What's the opposite? Well, divide by 3. And a lot of students at this point think they've gone wrong somewhere. So we cancel this through, so we get x on its own. And then they say to themselves, I can't do 56 divided by 3. Doesn't give me a whole number answer. But you're year 9 here, so be used to writing your answers as a fraction. 56 over 3. So at this level, please don't be afraid of leaving your answers as fractions or even as decimals. That is going to happen. Right, let's move on to this. So now we've got an inequality. So the thing we need to remember about inequalities, treat it the same way. And there's one exception to that, which we'll see, I think, on the next page. So we expand the brackets using the hook. So 4 times c is equal to 4c. 4 times minus 3 is equal to minus 12 is greater than 10. Notice I haven't really talked about the inequality much here because I'm still going to do it in the same way. Okay, so what's the opposite of minusing 12? Add 12 on both sides. This cancels. We're left with 4c is greater than, well, 10 plus 12 is 22. Again, don't be afraid of a fraction here. So what's the opposite of timesing 4? Well, dividing 4 on both sides. This cancels. So this cancels over here, sorry. So that's c, and then we get 22 over 4. I was a bit too keen on cancelling everything. You can leave your answer as this. This is perfectly fine. Just make sure you have the right inequality symbol here. So c is greater than 22 over 4. So don't let the inequality symbol put you off. The only exception to that is when you're multiplying or dividing on both sides by a negative. We will talk about that. So on to the next question. So Dexter, great name, is thinking of a number x. 2 more than 3 times his number is the same value as 13 less than 5 times his number. Okay, so let's break this down. So 2 more than 3 times his number is the same value as 13 less than 5 times his number. Okay, so this is really reading the question really carefully. Notice you've got the same value here, so there's going to be an equals in there, so I've used that bit of information. 2 more than 3 times his number. So we start with the multiplication first. 3 times his number, so 3 lots of this random number x. So I've used that, but I want 2 more than that, so I need to put a plus 2. And this is equal to the same value as 13 less than 5 times his number. 5 times x, that's 5 lots of x, but I want 13 less than that. So what I write down is minus 13. This is a really important skill to build up because you need to be able to break down a question and write it in mathematical notation. A really important question, this one. And from there, we need to solve the equation to find the value of x. Now, generally, I put the side with the largest amount of x on the left-hand side. So all I'm going to do before I start is I'm going to flip it. And I'm allowed to do this because the two things are equal to each other. Now, these x's are kind of annoying. The general strategy here is to remove the least amount of x. Notice 3x is the least amount of x. 3x is less than 5x. So what's the opposite of adding 3x? Well, minusing 3x from both sides. This cancels, which is the whole point of the operation, leaving us just with 2 here. 5x minus 3x is equal to 2x. Leave that 13 alone. We'll deal with that now. Now we've got this two-step equation, and we've seen how to deal with this before. The minus 13 is annoying. The opposite of that is plus 13 on both sides. This cancels. We're left with 2x. 2 plus 13 is equal to 15. And then that 2 is annoying, so we want to divide by 2 on both sides. Notice, once you get the hang of this, it's the same procedure again and again and again. So, cross that out, we're left with x equals, and I'm going to write my answer as 15 over 2. You'll see in the mark scheme that they like to write it as a decimal for some unknown reason as 7.5, but just notice both things are the same. Now we're on to this question here, solve the inequality. Now I said here, when we've got negatives, you have to be a little bit more careful. You're going to see that in this question. So we're going to start off in the same way. This plus 6 is kind of annoying because it's next to the minus 2y. What's the opposite of adding 6? Well, minusing 6 on both sides. 2 minus 6 is equal to minus 4 is greater than, well, this cancels, leaving us with minus 2y. Now, this is where the inequality is important, because what we're going to do at this point is we are going to divide by negative 2 on both sides, because we want to get rid of the minus 2. So this cancels, leaving us just with y. When you divide or multiply it by a negative number, you have to switch that from a greater than sign to a less than sign. That's really, really important. So minus 4 divided by minus 2 on the other side gives us positive 2. And generally we can either write the answer as 2 is greater than y, so that would be acceptable, or you can write it the other way round and give yourself y is greater than 2. So as long as you write that in the correct way, 2 is less than y, I should put, sorry. I didn't copy it across correctly. So 2 is less than y, or y is greater than 2. You can write it both ways and both would be equally valid. Just be very careful in this stage here. I'm going to highlight it for you, so you need to review this. Actually, if you need to review this, I did a 3-part series on inequalities, so please do check that out above. Right, question 6. So we have an equation of a straight line, x equals 2y minus 1. Write the equation in the form y equals mx plus c. So we're going to solve it kind of in the same way. We want y on its own. So the first thing I'm going to do, I'm going to put the thing that I want on the left-hand side. You're allowed to do this because it's an equation. At this point, I want to get the y on its own, kind of solve for y. So what's the opposite of minus 1? Well, I'm going to add 1 on both sides. If I do that, this cancels, leaving us 2y is equal to x plus 1. And now we have to get it in this particular form that they're looking for. So I'm still going to do the opposite of times by 2. That is divide by 2 on both sides. This cancels, leaving us y. But notice when I divide by 2, I want to do the same to both. So x divided by 2, well, that's just a half of x. 1 divided by 2 is just a half. Notice I have to be very careful in that last stage to make sure I write it in exactly the way that they want. So I've written it as something x plus something, which is the answer here. And this one here, we want to make h the subject of the formula, very similar to what we did in question 7. Generally, the thing that I want, I put to the left-hand side. So we get the square root of 2h over 5 is equal to p. Having great fun here. I love this kind of stuff. And then we need to get the h on its own. Well, this was what's called a square root is really, really annoying. The opposite of square rooting is squaring on both sides. So I'm going to write that in words, squaring on both sides. This has the opposite effect of the square root. So we're left with 2h over 5. And now we want to do p squared. P squared we write as p with that little 2 up at the top, p squared. Once we've done that, it works in exactly the same way as before. So the divide by 5 is annoying. So what's the opposite of that? Well, let's times by 5 on both sides. Again, just getting the h on its own one step at a time. P squared times 5 is 5p squared, and then the 2 is annoying, so what's the opposite of timesing by 2? Divide by 2 on both sides. We finally get what we want here, which is h on its own, which is 5p squared over 2. That can be written in some slightly different ways, but the mark scheme likes it written like this. And we got our answer. So you can check through the answers and see how they've written it as well. Notice this OE is an important thing to realize. This means or equivalent. So that means if I wrote it as a decimal, that is absolutely fine as well. So just be aware of that in the mark scheme for White Rose Maths. There we are. At what's called testing conjectures. So this is really thinking mathematically and trying to look for patterns, which is a really good brain training for you for some of the more complicated courses when you get older. So the first thing that we need to do is circle the prime numbers. Now remember, 1 is not a prime number. I'm going to cross it out here just to make a point here because it's only got one factor. A prime number always has exactly 2 factors. So if we look at 2, well, 2 has 2 factors, 1 and 2, because 1 times 2 is 2. So that is prime. Likewise, 3 is prime because it has 2 factors, 1 and 3. 1 times 3 is 3. 11 is also prime because there's no other number other than 1 and 11 that go into 11. So that's also prime. Notice 21 is not prime because of 7 times 3. And 35 is not prime because of 7 times 5. So the only 3 prime numbers here are equal to 2, 3, and 11. Now we need to decide if each statement is true or false and explain our answers. So all the factors of 20 are less than 20. Well, this is going to be false because, and there is one counterexample here, 20 is a factor of 20. Notice you want strictly less than 20, but 20 is equal to 20, therefore it must be false. Multiples of 4 are also multiples of 2. Well, that's going to be true because all numbers in the 4 times table, so all numbers in 4 times table, so that's 4, 8, 12, 16, are also in the 2 times table. So it's just about trying to explain yourself mathematically when you look at these problems. Next one here, x equals 5 is a solution to the equation 12 minus x is equal to 7. Now we could solve it like in the previous part of the video, but we can also do something called substitution. So if I sub 5 in equation, so let's see what happens. Well, 12 minus 5, that is equal to 7. So that is going to be true. Always state very clearly if it's true or if it's false, and then obviously give that clear reason why. Good. Right, now are the statements always true, sometimes true, or never true? And then we need to circle it, which answer is correct, and explain the reasoning. Multiples of 3 are odd. So the multiples of 3 are going to be 3, 6, 9, 12, dot, dot, dot. Well, 3 itself is odd, whereas 6 is even, and then 9 is odd, 12 is even. So this one is sometimes true. Some of them are going to be odd, but then some of them are also even as well. And next one here, when you add 2 prime numbers, the answer is even. Okay, let's have a look at that. So if we just take the numbers we've got here, actually, 2, 3, and 11, let's test that out. So 2 plus 3 is equal to 5. Well, that's odd. 11 plus 3 is equal to 14. That's going to be even. And then, what's the one I haven't done yet? 11 plus 2. That's equal to 13. So that's odd. So this is a case of sometimes true again. So some are odd and some are even. So as long as you've shown some examples of trying it out, seeing if you can come to a always true, sometimes true, or never true conclusion. Now question 4 here, we need to show that 10% of 50 is the same as a third of 15. The way I would do this is work at the left hand side first. So remember to find 10% of 50. How many 10s go into 100? Well, 10. So we need to do 50 divided by 10. I will talk about that in a later chapter. And that gives me 5. The right hand side, so to find a third of 15, we divide by the bottom and times by the top. So we do 15 divided by 3 times 1. And that's going to be equal to 5. And notice the left hand side, therefore, the left hand side is equal to the right hand side. So that is going to be true. So 10% of 55 is the same as 1/3 of 15, which is always 5 as well. On to question 5. So we've got some expanding brackets. Interesting place to put this in, but why not? So remember to use the hook. So I always draw in my hook just to remind myself of what to do. 4 times x, that's equal to 4x. Remember to multiply here. So 4 times 3, well, that's equal to 12. So this will be 4x plus 12. And here, this is slightly different because we've got an x times x. Remember, x times x is not 2x. There's one thing to learn from this video. X times x is not 2x. It's equal to x squared with the small 2 at the top. And then we do x times 4, which gives us then 4x. Just be very careful about x times x. There's x squared. Please, please, please at home remember that. And we want to expand and simplify the following. So most teachers here, I'll follow in their footsteps as well, use what's called FOIL. So that tells us the order in which to multiply. So we're going to start with first, f for first. So the first 2 terms. So x times x is equal to x squared. Then we're going to do the outside terms. So we're going to do x times 7. That's equal to 7x. And then we do the inside terms, hence the I. So the 5 times x, that's equal to 5x. And then finally the last one, the one that we haven't done. I also call this the double hook. Notice you've got a hook at the top and a hook at the bottom. So 7 times 5 is equal to 35. But we're not finished at this point because we can collect the terms in the middle. So x squared stays as it is. 7x plus 5x is equal to 12x. And then 35 stays as is as well. Again, if you need to go through that question again, please do. I'm going through all of year 9 maths here, so I'm trying to go at a decent pace. But if you want to rewind, then please do by all means. Question 6. So Nisha is investigating the sequence given by the rule 4n plus 1. She makes 2 conjectures, so 2 ideas about it. Test the 2 conjectures to see if she is correct. All the terms in the sequence are odd. Right, the way I would do this is let's find out the first term. So the first term will be equal to, well, 4 lots of 1. We're looking for the first term, so n will be 1 plus 1. And let's see what that gives us. So 4 times 1 is 4, 4 plus 1 is 5. Second term, we do the same process, but this time we replace the n with a 2. See what that gives us. So 4 times 2 is 8, 8 plus 1 is 9. So that's also odd. And if we just do the third term to check, do 4 lots of 3 plus 1, that's equal to 13. That's also odd. And we're going up in 4s, so it's always going to be odd. So yes, that is true. Just by showing the first sequence of numbers, 5, 9, 13, you can carry on, of course, 17, 21, and you'll see each term is odd. Now, this is a classic question I've given my year 7s on occasion. So a particular term, so 203, is not a term in the sequence. The way I like to do this is to take our nth term and make it equal to 203, and then solve like a normal equation. So the plus 1 is annoying, so what's the opposite of adding 1? Minusing 1 on both sides. That cancels. We get 4n is equal to 202. And now the times by 4 is a bit annoying. So what's the opposite here? Well, we need to divide by 4. Now this is trickier to do mentally, so I'm going to use the bus stop method. I know you all love it at home. So if I do the bus stop method, again, I'll talk about this later on. So 4s into 2 go 0, 4s into 20 go 5 exactly, 4s into 2 go 0, remainder 2. So notice we get the remainder, actually it's 0.5, but if we get a remainder, then we know it's not in the sequence. Not in sequence. Let's go down here, unfortunately. So not in sequence. So in this case, that is going to be true. So not in the sequence, that is true. So we just need to be very clear. It's not in sequence, therefore it's true because it's not in the sequence. Okay, question 7. So the shapes highlighted on the grid are L8 and L27. Okay, so we've got this lovely L shape, like so. The total of numbers in L8, so this one is 53. Is that true? 15, 29, 37, 53. I agree. Find the total of the numbers in L27. So this is just a case of adding together 27, 33, 34, and 35. So I'm going to do this old school. Who needs calculators? Let's just work it out. So 7 plus 3 is 10. 19, carry the 1. 9, 11, 12. So I get 129. Don't forget your basic addition and subtraction. It's also very useful. Find an expression, this is trickier, for the total of the numbers in Lx. So imagine this is x. So I'm going to overwrite this and put an x here instead. How is this related to this number? Well, what do I do to 8 to get to 14? Well, I add 6. What do I do to 27 to get to 33? I add 6. So essentially, we're going to get our general term. I'll try and draw out a nice diagram here, where this is going to be x. This will be x plus 6. And then this, of course, is one more, so x plus 7. Hopefully you can see this okay. And then this will be x plus 8. So to write a general term, all we need to do is add these 4 blocks together. So we need to add x plus 6 plus x plus 7 plus x plus 8. That's 4 lots of x plus, and let's do some mental maths here. So we have 7 plus 6 is 13, 13 plus 8 is 21. So in general, this will be equal to 4x plus 21. Now if the grid were continued, which L shape would have a total of 533? So we want this expression here, the 4x plus 21 from before, to equal 533. Again, we solve in exactly the same way. So the plus 21's annoying, so we do minus 21 on both sides. Need a little bit of room here in a moment. This cancels, gives us 4x is equal to 512. Looks like a good number. 4 is going to go into. So what I'm going to do down here is I'm going to do exactly the same as before. I'm going to use a bit of bus stop. So opposite of timesing by 4 is dividing by 4. And this cancels, giving us x equals. And now we just need to do the bus stop on this. And let's work our way through. So 4s into 5 go 1, remainder 1. 4s into 11 go 2, remainder 3. And then 4s into 32 go 8. So I get the answer of, just checking I've done everything correctly here. Yeah, 128. So my answer is 128. Now the answer down there is 129. I'm just wondering why that's the case. No, that's definitely 128. I'm happy with that. Did I subtract this correctly? I did. Yeah, so I just say answers x equals 128, and that's my final answer. So it looks like we're going to disagree with the mark scheme here. That's the first time in this video. Oh no, you do get 128. Okay, I wrote that down incorrectly. So you do get 128 there as well. Okay, do check through the answers and make sure you're happy with the way I've gone through this as well. That's the first page, and then that's the second page there. Okay, and on to three-dimensional shapes. So make sure you've got a calculator handy a bit later on in this section. So the first thing we need to do is match the three-dimensional shapes with their mathematical names. So a sphere looks like a ball, so we want to match the sphere up to this. You need to learn these off by heart. A cylinder, so a cylinder is this shape here, which has a circle as a top, and it's the same shape going all the way through. A cone looks like an ice cream cone, so think about ice creams. I certainly do, and it looks like that. And then the last one, which looks kind of complicated, tetrahedron, in reality is just a triangle-based pyramid, is the last one. So the key technique here is to use elimination. I left tetrahedron, the hardest one, until last. I can use elimination. Now we need to circle the shape that is not a prism. So a prism, remember, has the same shape going all the way through. All the way through. So if we look at our first shape, so the cube, notice the square, so if I take the square here, goes all the way through our shape and doesn't really change. Likewise here, the triangular prism, the triangle doesn't change as it goes all the way through. And likewise, although this is harder to see here, this side doesn't change as it goes all the way through. The only one that does change as you go all the way through is the sphere. So we're going to circle that as our correct answer. Circling a sphere, that's kind of interesting. So that is the answer for question 2. Question 3, we need to complete the diagram to show the net of a cube. There are many different versions of this. The key thing we need to remember, this is a cube, which means when we draw this in, every square needs to be the same. Now, probably the easiest one to do here is this one I always remember, the so-called T. So I'm just going to draw a T in. Notice my red squares I'm drawing in are all the same size. So this is going to be my net of a cube. There are alternatives. You could have put this square here over here. That also works as well. But just try and visualize in your mind how it all folds up to make the cube. Question 4. So 1 litre is equal to 1,000 cubic centimetres. So keep that in mind. I'm giving you that for a reason. And we need to find the volume of the cuboid in litres. So we're going to need to convert at the end. Now, to find the volume of a shape, it's one of the easiest formula to remember. It's just length times width times height. So essentially we take each of these numbers, 80, 50 and 30, and multiply them together. So 80 times 50 times 30. Now you could rush to your calculator at this point, but I'm just going to multiply this mentally. So 8 times 5 is 40, 40 times 3 is 120, and we've got 1, 2, 3 zeros, so 1, 2, 3 zeros. So this is how much it is in terms of cubic centimetres, but we want the answer in litres. So what do we do to go from 1,000 to 1? We need to divide by 1,000, so our final answer here will be 120,000 divided by 1,000. And what we can do here is just go 1, 2, 3. So that's going to be just 120 litres. Okay, if you've got other ways of working that out, of course, and you can reach for your calculator, then that's absolutely fine as well. On to question 5, the classic plans and elevations question. So the diagram shows a three-dimensional shape made with 5 1 centimetre cubes. Notice our grid here is also in 1 centimetre squares. On the grid, draw the front elevation, side and plan view. So the front, you have to imagine, ignore everything else, just imagine what you see. So we see this one, we see this one, we see this one, and we see this one. So we're going to go 3 along. So 1, 2, and then 3, and then we're going to go upwards for 1. So all we're doing is imagine you're just looking straight ahead at the shape. What sides do you see? Now when you start doing things like side elevation, this gets a little bit trickier. Let's do this in a different color. So we're going from this side now. So we're going to see this one, we're going to see this side here, and we're going to see the one at the top there. So that's going to give us something looking like this, where this and this represent these two, and then this is the one at the bottom here. And now we need to do the plan view, so from looking from above, and let's do this in green. So what do we see above? Well, we see this one, this one, this one, and this one. So we need to draw in a shape. Again, you can have rotations of this and you're absolutely fine as well. Making sure I've got the 2 there, 1 there, and there we are. So that one, that one, that one, that one, and that matches up with what we have here. Now the volume of a prism is very similar to what we did with the volume of the cuboid. So notice we did essentially the area of the front face times the depth of the shape. And we can do the same here. So the volume is going to be the area of the cross section, so the front of it, so the cross section, and then we just times by the height or the depth of the shape. So if we transfer this for this particular prism, it's a really nicely designed question. We do 24.5 multiplied by 10. If we do that, then we're just going to get 245. But notice we need to state the units, which is important for all 2 marks. So 245 is fine. Notice we're working with volumes. It's going to be cubic units, and we have centimeters. So that's going to be cubic centimeters, like so. You may lose a mark in the exam if you do not put the correct units. So I'm going to highlight this to make a point. Make sure you put the correct units. In this case, cubic centimeters. Now on to the tougher 2 questions here on this section. So now we need to work out which is the greater surface area. That's the key word here, surface area, the cube or the cylinder, and show working. So let's work out the cube first of all. That's probably the easiest. Remember, if this is 2.1, this is also 2.1. So to work out the front face, so the area here, we do 2.1 times 2.1. But then how many of these faces do we have? Well, we've got 1, 2, 3 at the back, 4, 5, and 6. So we need to multiply that answer by 6. So notice I'm trying to write all the working here before I reach for my calculator, which is what I'm going to do now. So I've got a very fancy calculator here, but again, just a standard calculator at home will be fine as well. So we're going to do 2.1, and we're going to multiply that by 2.1. And then we're going to multiply that whole answer by 6. We can do it in any way around. It works very nicely. So the answer here we get is 26.46. So I'm going to add that in, 26.46. Because area, we're going to put square centimeters. Now the cylinder is a little bit more tricky. But again, I'm going to try and write everything I need first and then write my working in. Now the first thing we can do is work out the area of the top face and the bottom face, which is just the area of the circle. Notice we don't have the radius here, we have the diameter. So to get the radius, we need to divide 2.1 by 2, which is 1.05 centimeters. So to work out the top face and bottom face, we do pi times 1.05 squared. Remember, the area of a circle is equal to pi r squared. That's really important. And we're going to multiply that by 2. So we'll do that in a moment. And then we need to add on the area of the curved face. So if I use a different color here, the area of the curved face that goes all the way round. And to work that out, there is a formula for this. So the curved surface area is equal to 2 pi r h. So we need to do 2 times pi times the radius, which is 1.05, times the height of the shape, which is 2.1. Only once I've got that do I then put all of this into my calculator. Right, so let's go through this. So careful with the brackets. So we want pi times 1.05 squared times 2, because you've got the top face and the bottom face, plus 2 times pi times 1.05 times the height, which is 2.1. Make sure the brackets are in the right places. Press enter, and I get the answer of 20.78. So let's pop that across. So equals 20.78 dot dot dot. Check I'm getting the right answers. I am. There we are. Perfect. And notice that 26.46 is greater than 20.78. So therefore cube has the greatest surface area. So notice I've been very efficient with showing my working here, even though it's a 5-mark question and you need to put lots of detail. Notice I'm picking up lots of method marks by writing it in one very simple calculation. Now the last part here, the volume of a sphere is given by the formula V equals 4/3 pi r cubed. You need to know that at iGCSE and GCSE and find the volume of a sphere with diameter 7. So notice we need the radius here, not the diameter. So to work out the radius, we need half of the diameter, which is equal to 3.5. So don't fall for that trick. And once you've got that, then we just put in the volume. So volume is equal to 4/3 pi times 3.5 cubed. This is where the calculator comes into play. Right, so we've got a fraction first of all. So 4/3 times pi, our favourite number, times 3.5. The Q button you can do quite nicely here by pressing this and then just pressing 3. Does things very nicely. So you get 179.59. 179.59. And generally I round to 3 significant figures here. So 1, 2, 3. The 5 rounds the 9 upwards. So it's going to be approximately equal to 180 cubic centimeters, like so. Right, check your answers so you can go through everything that I've just talked about in this particular section, a slightly smaller section, so make sure you're happy with all the parts here. Notice for showing the working here, I've tried to keep it very efficient. I've combined these two into one step. I've combined these two into one step as well to really make, when you're in the exam, every second count and making sure you're efficient with your working as possible. Okay, and on to number work. So some of this is quite straightforward at the beginning, but look out for the standard form a bit later on. So the first thing we need to do here is which number is an integer. So this word integer, all that means is a whole number. So we're just looking for which of these is a whole number. So it's going to be the 6. So integer is equal to whole number. Please do remember that definition. Now on to a bit of multiplying here. So 196 times 5. This gives me an opportunity to use the lattice. So I'm going to draw out my lattice. You may not be familiar with this particular method, but I absolutely love it, and particularly with students from year 7, 8 and 9. So I'm going to write down 196. I'm going to put a 5 here, so writing out this multiplication. And all I need to do is actually work out some really easy multiplications. So 1 times 5 is equal to 5. 9 times 5 is equal to 45. 6 times 5 is equal to 30. And all I need to do at this point is just add up the diagonal rows. So this is 0. 5 plus 3 is equal to 8. 5 plus 4 is equal to 9. And that's going to be my final answer, 980. If you haven't seen that method before, please do go rewind and look at that method again. It's so nice, it's so easy, and you don't get confused with adding extra zeros with the traditional method. Now, we want to calculate 5/9 plus a third. The easiest way of doing this is changing one fraction or the other into the same denominator. So I'm going to leave the 5/9 as it is. Now notice 1/3, I can multiply top and bottom by 3. To give me a fraction out of 9 that I can work with. So 3 times 3 at the bottom is equal to 9, and 1 times 3 is equal to 3. These fractions are the same, but the reason is I'm unsimplifying our fraction here because it makes it really, really easy then to add the two fractions together. When you have the same denominator, all you need to do is leave the denominator alone, the bottom alone, and then just do 5 plus 3, which is equal to 8. So this question here, all we get then is 8/9. Now question 4 is the classic negative number question, and I try and do this in 2 steps, so do listen carefully. So here we've got -5 plus -1. So if we have a plus and a minus next to each other, then that becomes a minus. So I'm leaving everything else alone here, apart from the plus and minus next to each other is equal to a minus. So we get -5 minus 1. And now I think of it like temperature. So once I've got rid of anything with 2 symbols next to each other, then I think of temperature. So it's -5 degrees, it gets 1 degree colder. That's pretty cold. Then it's going to be -6. Likewise here, I see 2 minuses next to each other. That's really important. So 2 minuses next to each other give you a plus. And then we actually get a really straightforward calculation 2 plus 7 is equal to 9. There we are, is equal to 9. There we are, perfect. Right, question 5. So we've got 126 written as product of prime factors, and he says the highest common factor of 126 and 420 is 7. Why is she incorrect? Well, they do share a 7, but they also share a 2 as well. So if they share a 7 and share a 2, then 14 will also be a factor. So also a factor of both, and 14 is greater than 7. So I'm trying to use the correct mathematical notation here as well. And now we need to find the highest common factor. So we need to find everything that they share. So they share a 7, they share 1, 3, and they share 1, 2. So to work out the highest common factor, you have to draw a Venn diagram, which is always good. So we just need to do 2 times 3 times 7. So 2 times 3 times 7, and that's equal to 42. 2 times 3 is 6, 6 times 7 is 42. So it's nice when they write the question like that. It means you'd have to go through that process of drawing factor trees. So thank you, White Rose Maths, for not having to go through that particular process. Right, 23,451 people attend a rugby match. 8,376 of these are season ticket holders. And how many of these people are not season ticket holders? Okay, so we need to find the difference between everyone that attends and those that are season ticket holders. So we need to do a subtraction here. 23,451 minus 8,376. Now notice, by lining it up very, very carefully, I make sure I don't make any particular errors. Let's go back to my red pen. Okay, so 1 minus 6 doesn't work, so we cross out 5, put that to 4, carry the 1. So 11 minus 6 is equal to 5. Always good to review this. Then we go 4 minus 7 doesn't work. We cross out 4 here, 3, pop the 1 across. 14 minus 7 is 7. 3 minus 3 is 0. That's helpful. 3 minus 8 doesn't work. Cross out a 1 here. Carry it across. I'm sure you've done this many, many, many times. And that gives us 13 minus 8 is 5. And then the 1, giving us the final answer of 15,075. So these worded questions, just make sure you read them carefully and understand exactly what they expect you to do. So Eva has 4 meters of ribbon for wrapping gifts. She needs 2/3 of a meter for each gift. Okay, how many gifts can Eva wrap? So how many 2/3 go into 4 meters? Whenever you phrase it like that, that's going to be a division question. How many go into something is a division. So the question's actually asking us how to do 4 divided by 2/3. This is where I get to do my favorite rhythm here. So keep it, switch it, flip it. Now what do I mean by that? Well, we keep the first number, we switch this to a times, and then we flip this fraction to 3/2. At this point, we're not totally finished. We can do some cross cancelling, which is always helpful. So 2 goes into 2 once, 2 goes into 4 twice. So now we've broken this down into essentially 2 times 3, which is always nice when it's so straightforward. So that's going to give us 6 gifts. Now we can check that by doing 2/3 plus 2/3 plus 2/3 6 times, and that should equal to 4 if everything's worked out very nicely. On to question 8. So we have 2 in standard form. So 8 times 10 to the power of 6. So we write that out long way. That's basically 8 and then 6 zeros. So 1, 2, 3, 4, 5, 6. Q here will be 4 and then 5 zeros. So 4, 1, 2, 3, 4, 5. So we can always write these out as ordinary numbers if this is a little bit tricky. Now we need to work out the value of each expression. Since I've written these out as whole numbers, this is probably the easiest way of doing it. So we're going to do 8 million, because it's got 6 zeros, minus 400,000. And that's going to give us 7,600,000. So you can even do it mentally at this point once you've written out the numbers. Now, one of the advantages of having it in standard form, when it comes to dividing, we can actually do this really, really nicely. So we can do 8 times 10 to the power of 6 divided by 4 times 10 to the power of 5. So what we do here is we just do 8 divided by 4, that's equal to 2. And then we do 10 to the power of 6 divided by 10 to the power of 5. So if I write this out separately, when we're working with indices and we're dividing, we minus them. So we do 6 minus 5. That just gives us, well, just 10 to the power of 1, which is 10. So by using standard form, we've actually sped up the process here. And 2 times 10, well, that's just going to be equal to 20, like so. And on to the harder question here, which is my favourite, surds. You've got to love surds. Which one is equal to 2 root 3? And justify your answer. Okay, so you want to try and split these up using square numbers. Notice no square numbers go into this one, so it can't be that. Root 12 is equal to the same as root 4 times 3. Root 18 is the same as 9 times 2. So they both split up quite nicely. The reason we want to write it like this is that we can continue this and write it as root 4 times root 3. This here can write as root 9 times root 2. Well, root 4 is equal to 2, so that gives us 2 root 3, which is actually what we wanted. This would be equal to 3 root 2, which is not what we wanted. So therefore, root 12 is the answer. And when they say justify your answer here, by showing this working, showing this logical progression through, you've actually shown that root 12 is equal to 2 root 3. Feel free to go through and check your answers. So check everything that I've done here, even my handy lattice method that I did earlier, and of course the last page as well. So make sure you're really happy with these number skills. They're the foundation of any GCSE or iGCSE course you're going to do. Okay, and on to percentages, which is a very important topic across the board. So question 1, we want to write 3/4 as a percentage. So our general tactic here, our general strategy, is we want to write this as a fraction out of 100. Remember, percent means out of 100, %, yeah? So what do we do to 4? To get to 100, well, we need to multiply by 25. So whatever we do to the bottom, we're going to do to the top as well. So we do 3 times 25, that gives us 75. And the reason we did this is we can just take the top of the fraction and write it into our answer box. So 3/4 is equal to the same as 75%. And you can do that with pretty much any fraction. 1/8 you have to be a little bit more careful with. So number 2, we need to match each statement to the correct calculation. So let's start with the first one. So if we're increasing 20 by 15%, essentially what we're doing is we're taking 100% and we're adding 15% to it. That gives us 115%. Now as a decimal, so by dividing by 100, we get that as 1.15. So this calculation here must be equivalent to increasing by 15%. Decreasing works in a very, very similar way. So we do 100% minus 15% because we're decreasing, getting smaller. That's equal to 85%. And you can probably see where I'm going with this. So this is a decimal is 0.85. So this must match up here. And then by elimination, that classic technique, then this one here must match up to just finding 15% on its own. Now question 3, Juan's wage is £10.40 per hour and he gets a 10% pay rise. That's good with inflation at 7%. And what is his new hourly wage? So we need to first of all work out what 10% of £10.40 is. Well, that's very fortunate because that's quite an easy one to work out. We just need to take our 10.4, this number here, and divide by 10. That gives us then 1.04 or £1.04. And because it's a pay rise, always better a pay rise than a pay cut, then we need to add it on to the original. So our answer will be 10.4 adding on then the 1.04, that gives us 11.44. Like so. Perfect. Now at this point we're going to actually start needing to use our calculator, so make sure you've got that ready. So question 4, Tom and Lorna sat the same test. Tom scored 70%, but Lorna scored 29 out of 40, and we want to know who got the highest score. So the way I tend to do this is let's take Lorna's score, so this is 29 out of 40, and let's convert it to a percentage by using the calculator. So what we're going to do here is we're going to type in our fraction 29. That's not nice. Right, 29 out of 40. So we pop that into the calculator. And at the moment it gives us a fraction. By pressing Control Enter or ST button, we get 0.725. That's not a percentage yet because we need to take that answer and times it by 100. That gives us the percentage of 72.5%. So let's come back. So this is 72.5%, and that's more than 70%. So 72.5%, that's greater than 70%. So Lorna did better. So the key thing with this kind of question is making sure you convert it to the same, both percentages, both fractions, or both decimals. Now question 5, Mo spends £15 on ingredients to make 40 cookies, but sells all those cookies for 50p each, or if we put this in pounds, this would be 0.50, and we need to work out Mo's percentage profits. So first of all, we need to work out the revenue, so how much she actually makes from sales. The way we do this is we take how much she sells them each for, so 0.5, and then multiply it by 40. That's a nice calculation to work out, so half of 40, that's equal to £20. So profit is equal to, well, revenue minus costs. So revenue minus costs. So she made £20 from sales, spent £15 on ingredients, so made a profit of £5. But we're not finished at this point, because now we need to work out the percentage profits. That's the most important thing here. And so what we need to do is you take that profit she made, divide it by the original, which in this case is 15, and then multiply it by 100. So at this point, I'm going to go to the calculator, pop that in, and work it out. So we take our fraction that we worked out before, so 5 divided by 15 times by 100, and we get a big number. There we are, so 33.3333. So let's write that nice and clearly. So we get a 33.3. And remember, it's got a recurring, so that 3 that goes on forever. In the British system, we tend to write a dot over the top to indicate that is going on forever. Right, on to question 6. So Rosie jumps 32 centimeters in the air. It's pretty good. Annie jumps 8% higher than Rosie. So how high does Annie jump? So the way I like to work this out, 8% higher or bigger. So therefore Annie is going to be 108%. So take the original 32 as 100%. She's jumping 8% higher. So that's going to be 108% of that 32 centimeters. Now if we convert that into something we can calculate, 108, well that percent, that's the same as 1.08. Going to multiply that by 32, and again the calculator is very handy here, we can then work it out. So we type in 1.08, multiply that by 32, and that gives us then 34.56. So we're going to write in 34.56 centimeters, like so, to 2 decimal places. Question 7, so this is a bit more involved. So Dora's back again. She purchased a kitchen mixer for £425. She pays a 40% deposit, so she pays 40% of that amount money, and then the remaining amount left is paid in monthly instalments of £17. How much monthly instalments will Dora need to pay? So we need to do this nice and logically and take our step through. First of all, we need to work out 40% of the whole amount, so 425. Well, notice 40% is the same as 0.4. So the first thing we're going to do on our calculator is work out 0.4 times 425. So 0.4 times 425. So our deposit will be 170. So I'll quickly do this here. Let's take that off and see how much she has remaining to pay. So 255, perfect. So this is equal to 170. So she has £255 remaining. And she's going to pay this off over £17 per month. So to work out how many months, we need to then do 255 and then divide that by 17. Yeah, okay, I'm going to go to the calculator and do that. So we're going to take that answer, divided by 17, giving us 15 exactly. Always a good sign when that is a whole number, an integer. So that's going to give us 15. So we're going to get 15 months to take. Good, good. Again, it's all about reading the question with these more tricky questions towards the end. The cost of a laptop increased by 25% between 2015 and 2019. And we know the price now, so the laptop cost £1,000. How much did it cost, so in the past tense, in 2015? So imagine it was 100% in 2015, but it's increased 25% to 2019. So what we're saying here is 125% is equal to £1,000, because that's how much it costs now. And we want to work out how much it did cost. So we want to work out the 400% at the end. Now, there's a couple of ways we can do this. We can use the so-called unitary method. So we're going to work out what 1% is, and then we can work out 100%. So essentially what we do here, what do we do to 125 to get to 1? Well, we divide by 125. And what do we do to 1 to get to 100? We multiply by 100. And so we just need to make sure we do the same on both sides. So we divide by 125 first, and then multiply by 100. Again, we can do both of these on the calculator. So we take 1,000, we divide that by 125, that gives us 8, and then we times by 100, giving us 800. So 1% would be £8, and 100%, which is what it cost in 2015, is equal to £800. So the key thing here is just to write out your working really clearly, visualizing exactly what you know already and what you want to find. Now question 9 builds on this. So the average house price in 2007 was 5% lower than in 2006, and then the average house price in 2008 was 5% greater than in 2007. So it's gone down by 5% and then it's increased by 5%. We need to explain why the average house price in 2008 is not the same as the average house price in 2006. So say we had a house costing 100,000. Seems reasonable. If it's 5% lower, then we need to multiply by 0.95. Similar way to how we did question 2 over here. But then it increased by 5%. So then we take whatever the answer is to that and then multiply by 1.05, increasing by 5%. And if we work this answer out, so we go to the calculator again. So we type in, just using 100,000 example here, we times by 0.95, and then take that answer and then times by 1.05. Notice we don't get back to beginning, we get 99,750. So let's put that in, so 99,750, and notice here that 99,750 is not the same as 100,000. So going through that process logically, that helps you actually show, well, actually these two amounts of money are not actually the same. So 5% lower, 5% higher, it's not the same amount that you're taking 5% of. That's the key thing to realize here. And this works on a similar way to what we've seen now already. So cars purchased are 11,500. First year, it depreciates, so it goes downwards by 15. And each year after that, the value of the car will depreciate by 10%. What's the value of the car at the end of the 3 years? So we can write this in one calculation. So we start with 11,500. It decreases by 15%, so multiply by 0.85. 100% minus 15% is 85%. Then we take that answer and then we multiply twice by, well, depreciating by 10%. So that's going to be 0.9 and then 0.9 again. So once we've written the calculation clearly for the two method marks, now we're going to actually put this into our calculator. So 11,500 multiplied by 0.85, then we multiply by 0.9, and then for the third year the 0.9 again. That gives us 7,917.75. Okay, we don't need to do much rounding here. 17.75, perfect. So the key thing with this particular section here is making sure you write really clear you're working and make sure you can visualize, are you going into the past, you're going into the future, and then what process you need to do for that. Okay, check your answers. So check exactly what I've done here and show the key working to get all the marks. And that's the second page here as well. So this is probably more the trickiest parts of the Year 9 Maths course. So making sure you really understand this compound interest procedure, this depreciation procedure, working between reverse percentage change. That's going to set you up really nicely for the iGCSE and the GCSE courses. Okay, and on to money calculations. Also useful for you, of course, in real life and understanding exactly how tax works and how to convert between different currencies. So very, very important topic, not just for Year 9, but also your general life as well. So we have a back statement just here from Annie. And we need to work out how much or what did Annie spend most of the money on. So we're looking at the debit column here. We're looking for the highest number in the debit column, which is this one here. And she spent that on her phone bill. So we're not looking for the amount of money here, but just exactly what she spent it on. And now we need to find out the total amount of money that Annie paid into the account. So it's going to be our credit column. So she paid in £22.50 here and a bank transfer of £50. So we need to add together £50, £22.50, and that then gives us £72.50. Really important skill to know how to work this out. And now we need to work out the difference between Annie's opening and closing balance. So opening balance was £80.50 and her closing balance was £94.71. So we need to find the difference between £94.71 and £80.50. Again, we can do this mentally here, make our life a little bit easier. So it's going to be £14.21. So really important skill. Make sure you know when you do get a bank statement when you're a bit older exactly how it works and how to work these things out. Now in the UK the rate of VAT is 20%. Back in the old days it was 17.5%, so 20% is easier to deal with. The price of a camera excluding VAT, so without it, is £96, and we need to calculate the price of the camera including VAT. So what we want to do is we want to add 20% to £96. Now we saw this in the percentages section. So if we're increasing by 20%, that's equal to 120%, which as a decimal will be 1.2. So the nice easy calculation here is just take our 96 and then multiply it by 1.2. This is where the calculator comes in. So we type in 96 times 1.2. And that gives us a calculation of £115.20. So we pop that in, making sure we keep this in money. Now Scott earns £7.50 per hour, and he works 8 hours per day and 4 days in the week. How much does he earn in that week? So he's earning 8 hours a day and 4 days a week, then he is working 32 hours per week. Because 8 times 4 is equal to 32. He's earning £7.50 an hour, so we do 7.5 times 32. So we take the amount per hour, he's working 32 hours in the week, so we just multiply those two numbers together. Again, we can do this on the calculator. 7.5 times 32. That gives us £240 in the week. There we are. So again, that's a useful calculation you need to be able to do. Again, if you start doing a part-time job, then these things are very, very important. Now, exchange rate for British pounds to Indian rupees is £1 is equal to 98 Indian rupees. And we need to convert both from pounds to rupees and then later from rupees to pounds. So if we're going from pounds to rupees, we're going in this direction. So we're going to be multiplying by 98. So we take our 40 and multiply by 98, which we'll do in a second. If we're working the other way round, so we're going from rupees to pounds, we need to divide. So we take 5,194 and then we divide by 98. We'll do both of those on the calculator now. So we do 40 times 98, we have 3,920, and now let's do the other calculation, 5,194, and divided by exchange rate, so 98 is equal to 53. So let's pop both those in. So the first one will be 3,920 rupees, and then this will be equal to 53 pounds. Perfect. And now we're on to the classic Best Buy question here. So two shops sell the same pens. This is something you probably do in real life as well. So you see two offers and you want to work out which one has the better value for money. Very important phrase to understand. The easiest way to do this is to work out the price for one pen and see which one is cheaper. So the way we do this, we take the £1.68 and divide by 10, how many there are in the pack, and then work out what the price is for one pen, and we do exactly the same calculation for the other shop as well. Now this one we can actually do in our head because it's dividing by 10, but we're going to need the calculator for the other one to see if it's cheaper than 0.168. So we do 1.98 divided by 12, gives us 0.165. So let's copy that across. Very, very close, but you can see that this one here is slightly cheaper. So On Point, great name for a shop, is going to get the price for the cheapest pen. Now on to some compound interest. So this is a formula you need to learn. So it has 4% compound interest per year. We start with 1,500 to invest over 2 years. And we actually want the interest. So we don't want the total amount at the end, but we want the interest. So the formula is, so the final amount is equal to the original. So what we start with, multiplied by what we call the multiplier. So I'll explain that in a moment, to the power of number of years. So that's our general formula for compound interest. So we put in our numbers, we start with 1,500. Our multiplier, so let's explain this now. We're increasing by 4%, so 100% plus 4%, that will give us 104%, and then we want that as a decimal. If you check out my percentages section, you'll see I go through that in a bit more detail, and we're doing this over 2 years. So that's going to be our calculation, which we're going to put, of course, into the calculator. So 1,500 times 1.04 to the power of 2. So that gives us our total amount of money, but we want the interest accrued, so the interest actually worked out. So if we take away the initial amount of money we started with, that will give us the pure interest that we need, so 122.4. So let's pop that across. So that's going to be our final answer, 1,622.40. Perfect. So just read the question carefully. We're not looking for the total amount at the end. We're just looking for the interest that Eric has accrued. Now Brett, great name, buys a drum kit for £1,250. Now the first thing is he pays a 20% deposit. So first of all, we want to take off that deposit because he's charged 15% interest on what's remaining. So first thing we need to do is we need to find 20% of 1,250. So that's going to be equal to, and you can do this on a calculator, it's going to be 250, and then we want to take that off. So 1,250, take away 250. So we're left with 1,000 to pay off. He's charged 15% interest on the remaining balance, and pays it off in 10 equally monthly installments. So what we do is we take the 1,000, 15% interest, so that's going to be times 1.15, so 115%. That gives us then 1,150. But he's paying that off over 10 equal installments. So we take that 1,150, divide that by 10. So he's going to be paying £115 per month to make sure he pays off that particular interest. Okay, and on to the last question, which is quite British orientated here because the personal allowance is how tax is calculated in the UK. So for the first £12,500, you do not pay any tax, and then you pay 20% tax up to the next 50,000, and then from there 40%. So Juan says that somebody who earns gross income of £40,000 pays £8,000 in tax. Now he's not correct because we don't take 20% of the whole amount. What we do is just take 20% of 40,000 minus 12,500. So you're only taxed on the difference between 40,000 and 12,500, which, you do mentally, is 27,500. So that's an important thing to realize about tax generally. You're not taxed the same on all your income, you're taxed in different bands, which is important to realize. And this calculation we're going to do now shows this. So work out the total amount of income tax payable on the salary of £75,000. Well, first of all, we're not paying any tax on the first 12,500, so you can ignore that. He's going to pay 0.2%, 20%, so 0.2 on the next 37,500. So we're going to pay that amount of tax. So if we do 37,500 plus 12,500, add those together, that gives you 50,000. So anything above 50,000, he's then taxed at 40%. So the difference between 50,000 and 75,000 is 25,000. So he's taxed 0.4 on that 25,000 extra that he or she earns. So now what we're going to do is put that into our calculator and work out how much you get taxed. So we're going to do 0.2 times 37,500 plus, here comes the big 40% tax. I live in Germany, so tax can be a little bit higher here in comparison. And if we do that calculation, we then get 17,500. So if you have a salary of £75,000, 17,500 of it goes on tax, and that can be towards a variety of different things as well. So that's how much he gets taxed. Right, you can check your answers, so you can go through exactly what I've gone through in the last 10-15 minutes or so, and make sure you're happy with all the steps I've gone through as well. Okay, and now we're on to the topic called deduction. Generally, this is about angle facts and working with angle facts with a little bit of algebra in there as well. So let's get started. So we need to work out the size of the angles marked with letters. So in this case, we want M, and give a reason for each answer. Okay, so the first thing to realize here is that angles on a straight line add up to 180. So I'm going to put a straight line, and they add to 180 degrees. The next thing I notice here is that we have this square by the angle, and that means it's a right angle, which means that's going to equal 90 degrees. So in order to work out what M is, we take the angles that we know so far, so 90 and 23, and add those together, which gives us 113. And so to calculate M, we need to do 180, so the entire straight line, minus these two angles added together. Excuse me. So if we do that, so we're going to do 180 minus 113. And if we do that, we get the angle of 67 degrees. Now, our next question here is we have 113 degrees here, and we have P here, and these angles are the same. So P is equal to 113 degrees. Notice it's out of 2 marks, so we need to give a reason. And the reason here is because the angles are vertically opposite, a very important phrase that we're going to talk about in the very next question. So These two are equal because they're vertically opposite. And now let's look at P and Q. Notice the shape that we have here, so I draw a line around it, is a parallelogram. And one fact you need to know about parallelograms is that opposite angles are equal. So opposite angles in parallelogram, just going to write that in, are equal. And they look equal as well. Always use that as a rough guide to help you with these kind of angle problems. And so Q is also equal to 113 degrees. On to question 2, and you need to know these phrases: alternate, corresponding, and vertically opposite. We'll start with vertically opposite since we've already seen that here. So notice if we take B is equal to D, so that this angle is equal to this angle, it has the same property as what we've just seen here. So B equals to D is because vertically opposite angles are equal. Let's look at the next one here. So B is equal to F. So notice we're looking at these two angles here. And what I'm going to do now is just draw around the shape slightly. So I'm going to draw a blue line in like so and like this. And notice we get an F shape, a kind of twisted F. We get an F shape. And as soon as we get this so-called F shape in mathematical language, that is known as corresponding. So with this one in mind, let me change back to the red. There we are. So B is equal to F, therefore it's because its corresponding angles are equal. And again, that elimination that's very important here, so B is equal to H, must be because of alternate angles. In fact, you get a Z shape when you actually put this together. So if I draw this in red, notice you get this Z shape going on. That means they're alternate angles. On to question 3. So we've got angles around a point here. Explain why 18x is equal to 360. Well, if we add up all these together, so 7x plus 6x plus 5x, that is equal to 18x. And we know that angles around a point, very important. So angles at a point, they add up to 360 degrees, which is very important. And now we need to find the size of the smaller angle. So it's going to be this 5x here. First of all, we need to work out what x is. And yep, we're back to equation solving. So we want to get the x on its own. 18's annoying. I keep saying this. So what's the opposite of timesing by 18? Well, we want to divide by 18 on both sides. This cancels, giving us x. And then 360 divided by 18. Well, 36 divided by 18 is 2. And add the 0. We're not finished because we need to find the size of the angle. So we need to work out 5 lots of x. So 5 lots of our answer, 20. And 5 times 20 is equal to 100 degrees, like so. Right, moving on to question 4. Decide whether each statement is always, sometimes, or never true. Circle your answers. Opposite angles in a rhombus are equal. Well, that is always, and I'm just going to show you why that's the case. If we go back to our question here, I told you the opposite angles in a parallelogram are equal. A rhombus is just a special version of a parallelogram. Therefore, we can use question 1 actually here to work out question 4 as being always. The next one's a bit trickier. So a quadrilateral with a pair of parallel sides has at least one line of symmetry. Now this is sometimes true. If I draw a trapezium where these are parallel, then sometimes it's going to have a line of symmetry down the middle. But I could also draw a trapezium as a right-angled trapezium where these are parallel, and then there's no such line of symmetry. So this fits into the sometimes category. I can do an example where it's true, but I can also do an example here where it's not true. Therefore, it fits into the sometimes category. Question 5, so the angles in a triangle are 5x minus 3, 9x, and 3x plus 13. Show that the triangle is right-angled. Now, this is a harder question because it doesn't really tell you what to do in the question. Generally, whenever you have x's in a question, you want to work out what that is. So, angles in a triangle, we know this as a fact that they add up to 180 degrees. So if we add together all these angles, they should equal 180 degrees. That means that 5x minus 3 plus 9x plus 3x plus 13 equals 180. And now we just need to simplify this, so collect up those like terms. Let's get the highlighter out. So collect up the x's first of all. So I'm just highlighting what we're collecting. So 5x plus 9x plus 3x, that is going to be equal to 17x. Minus 3 plus 13 is equal to plus 10, equals 180. And now we do our usual equation solving here. So what's the opposite of adding 10? Minusing 10. See how important equation solving is across the Year 9 scheme of learning. So this cancels. This gives us 17x. 180 minus 10 is 170. And then here, what's the opposite of timesing by 17? Well, dividing by 17 on both sides. This cancels, this goes. So x equals 170 divided by 17, and that's equal to 10. Now we're not finished at this point because we need to show the triangle is right angled, i.e. one angle, it only has to be one, is equal to 90 degrees. Well, there's an obvious candidate to try here, this 9x. If we know x is equal to 10, the 9 lots of x will be equal to 90. So the 9x is equal to 90 degrees, therefore it is right angled. I'm kind of running out of space here. So I like these style of questions, really getting to just think a little bit more about the question, not just do this, do this, do this, but some extra thinking and deduction here, which is of course the title of this slide. Now Mo has come back, has said a pentagon cannot contain 4 right angles. Is Mo's conjecture correct? And justify your answer. So the first thing we need to do here is the sum of angles in a pentagon. So to work this out, there is a formula. So we do 180 times the number of sides in a pentagon, which is 5, minus 2. And if we do this, we'll get 540 degrees. Now, if there are 4 right angles sum to give you 360 degrees. So the last angle must be equal to 540 minus 360, whatever's left. Unfortunately, that gives us 180 degrees, which doesn't actually form an angle. So in this case, Mo's conjecture is correct. So we need to write this in big letters for the examiner. Mo is correct. I'm running out of space slightly. Mo is correct. Because you try and add in the 5th angle, that's 180 degrees, but that just gives you a straight line, so it won't create a vertex. Right, have a look at the answers so you can see what I've put in. You can compare that with the white row scheme and exactly what they accept there as well. And then the last question. Notice question 7 I didn't go through because this involves using compasses and protractors, which is a little bit beyond the scope of this video. Okay, and on to Pythagoras' theorem, a really important topic as it goes into lots of trigonometry a bit later on in your mathematical career. So let's carry on. So work out the values of P and Q. So the area of the square, notice we've got these 4 lines here indicating it's a square, and we know this side is 5. So we also know that this side is also 5. So in order to work out P, all we need to do here is just 5 times 5. And that gives us then 25 square centimeters. For this one, we need to work backwards. So we know that if this is Q, because it's a square, this is Q as well. So we need to think what's backwards to squaring, so timesing by itself. So in order to work this out, we're going to have to square root 64. So something times something is equal to 64. What is that something? And that's going to be equal to 8 centimeters. Like so. Now our Pythagoras' theorem is written down in question 2 below. X squared plus y squared is z squared. Now z is what's known as the hypotenuse. So let me write that in. And that's always the largest side. So that's also something important to know. And most importantly for this question, it's always opposite the right angle. So you always know the hypotenuse but it's opposite the right angle. So we're looking for triangles here where the z is opposite the right angle. So this is correct, so let's tick this one because the z is opposite the right angle. Here it isn't, so we're going to leave that alone. In this case, we're not actually given the right angle, but we can't assume it then, so it can't be this one either. And here it's opposite the right angle, so it's got to be this one here. So the two triangles where this formula applies is both this one and this one here. And the way we like to use it, so the way I tend to use it here, is for the longer side, so for the hypotenuse, I'm going to put longer, then we can work out z very neatly by doing the square root of x squared plus y squared. And if you have a shorter side, so say we're looking for one of the shorter sides like x or z, then we do something very similar here, but instead we write a z squared minus the y squared. Okay, so it all depends if we're looking for the longer or shorter side. In this case here, because we're looking for this side, the unknown side, this is opposite the right angle, so we want to use the top formula. So z is equal to the square root of 6 squared plus 2.5 squared. Whereas for this one here, we're looking for one of the shorter sides, so we want to use the bottom formula. So let's call x is equal to the big side, 12.5 squared, minus 7.5 squared. So let's go to my calculator and work out each of these. Right, so we're going to use the square root button. So there we are. There's our big square root button. So 6 squared plus 2.5 squared, giving us 6.5. That's a very nice number. If you look at the second question, this is 12.5 squared minus 7.5 squared. So let's pop that in. If you're liking the content, please do consider liking the video. It does help a lot towards spreading this video to other Year 9 students that may need this working. And this gives me a nice value of 10. So in this case, no horrible decimals, which is always good. This is equal to 6.5, and this is equal to 10. Now question 4, we're given the perimeter of the square, so that's really important, is 36 meters. Now remember the perimeter, what that means, all the sides add up to 36. We also know each of the sides are the same, so we can actually work out a side here by just doing 36 divided by 4, which is equal to 8. It's not equal to 8, it's equal to 9. There we are. So this is 9, this is 9, this is 9, this is 9, and we want to work out the length of the diagonal. Notice we've actually got a right angle triangle here, which is very, very useful. So pop in the right angle like so. Because we're looking for that z, that longer side, we can use the top formula. So we go z is equal to the square root of 9 squared plus 9 squared. This is not going to be so nice in terms of the number, so let's go to the calculator. Hopefully it'll give us the answer. So same process as before, so we go to square root and we want 9 squared plus 9 squared, and in this time it gives us a horrible decimal, 12.727, so let's pop that in, 727, and this time we are going to round to one decimal place, so it'll be 12.7 to one decimal place. Just make sure you're rounding to something sensible. That's the key thing to do here. Right, on to question 5. It's being a little bit tricky here. So a triangle has a sides of length 48 millimeters, 5 centimeters and 1.4 centimeters. Is the triangle right angled? Now the first thing I notice here, we've got two different units, millimeters and centimeters. So I'm going to very quickly change the 48 millimeters into 4.8 centimeters. Remember, there are 10 millimeters in a centimeter. And now we need to check if the triangle is right angled. Well, our longest side here is 5 centimeters. So what we need to check, if we use our formula z squared equals x squared plus y squared, I'm first of all going to check the left hand side. So the 5 squared is equal to 25. And if we do the right hand side, we're going to check that 4.8 squared plus 1.4 squared, and we're going to see if that equals to 25 as well. Let's go and check. So we're going to check here. So we're going to go 4.8 squared plus 1.4 squared. Are we going to get 25? We do get 25 exactly. Perfect. So we get 25. So the left-hand side is equal to the right-hand side, therefore right angled. This is a good way of setting it out. Make the left-hand side work out that, work out the right-hand side, and then see if they're equal or not, as the case may be. Perfect. Now on to question 6. So the point P has coordinates 5, 7. Point Q's coordinates -1, -1. Find the length of the line segment. Now remember, this isn't the Pythagoras section, so it should involve Pythagoras in some way. What I tend to do with such questions is draw a very quick diagram. Again, nothing to scale, just to give me an idea of what I'm doing. So we're going 5, 7, so 5 along, 7 up. Let's pop that here. This is 5, 7, and Q is -1, -1. So let's pop that down here. Q -1, -1. And let's make this line segment between the two. Now, in order to actually use Pythagoras, we actually need to draw a triangle. So I'm going to draw in a fake triangle here, like so, to give us something to work with. The way we can actually work out the rise and run, if you remember the gradient section earlier, is by looking at the coordinates. So here we have a 7 and here we have a -1. So what do we do to -1 to get to 7? Well, we add 8. Yeah, -1 plus 8 is 7. So it's going to be equal to 8. Likewise, let's now look, let's use a different color, let's use yellow. So what do we do to -1 to get to 5? Well, we're going to add 6. So essentially now we've actually got a Pythagoras question from a slightly different context. Again, we're looking for that z, we're looking for that longest side. So all we need to do here is do the square root of 6 squared plus 8 squared and work this out. Now I can actually do this in my head here. This is actually equal to 10. You can check this on your calculator. So z will be equal to 10 units. Now on to a pretty tricky question here with a square base pyramid. So this is the net. So imagine you've got the square base pyramid and it's been folded out, and we need to work out the height of the square base pyramid. So if I do this in 3D, just to give you an idea of what's going on, again, my drawings are terrible. What we're actually looking to do here, get this in black, we're looking for the height of this pyramid. So going all the way down and hitting the midpoint of the square. So that gives us a hint what we need to look for before we even get started. Notice that this line here, going up to the apex here, we already have. So we've got that equal to 12 centimeters. What we want to do here is create a right angle triangle in 3D where we've got the hypotenuse. We want to work out that height. Let's call it h for height. And we'll need to find this side first. So we need to use what we did in question 4 here and actually look at the diagonal of the square, and we will need to find half of it. So we do this in the same way as we did before. So in order to find this length, let's mark in this length here, let's call this x. What we need to do here, because this is also 10 as well, is we're going to use Pythagoras. So x is equal to the square root of 10 squared plus 10 squared. But most importantly, we need to divide by 2, because we want half of this length, not the entire length of the diagonal. Now I'm going to leave this as a surd form, so I'm going to leave this as the square root of 100 plus 100 over 2, which is equal to the square root of 200 over 2. Notice I'm not reaching for my calculator straight away. Now once I've got that, I can now use the other formula for Pythagoras, because I'm looking for the shorter side here. So to work out h, we need to do the square root of, well, we want the big side, which is 12 squared, minus what we just worked out. So the square root of 200 over 2 all squared. So only at this point am I really reaching for that calculator, because I'm trying to really avoid these rounding errors. So let's go to my calculator and work out the final answer. Okay, so let's get the square root ready. We have 12 squared. Okay, let's make sure that we're putting the 12 in there. There we are, 12 squared minus, let's get a fraction. There we are, we want the square root of 200 over 2, close bracket, squared. Everything is where it should be. And we get our answer, final answer of 9.695. Let's pop that in. 9.695 ... And if we round that then to, two decimal places, we get 9.70 as our final answer. So notice drawing that 3D representation really helped exactly what we're looking for in the question, and from there it's using that Pythagoras in a slightly unfamiliar context. Right, you can have a look through the answers so you can see what I've gone through and how I've gone through it as well. I find that I think my videos are quite useful because I actually go through each of the steps you need to do in order to work it out, not just the answers. So you can see that last one was a little bit on the tricky side to actually work out the final answer for the height was 9.7 meters. Okay, so now let's look at some enlargements. So let's get started. So you tick the shapes, the shapes that are similar to A, so in the same proportion. So if we look at A, notice how many squares we have across, that's going to be 4, and how many squares down, that's 2. So we want any rectangle here that are in the same proportion. So we take the one down here, this is equal to 2 and this is 1. So notice this is the same rectangle as this one, just shrunk. Essentially each side is divided by 2, so that's correct. If we take this one here, then we've got 4 and 1. Notice that's not in the right proportion. So we've got 4 and 1, not 4 and 2, so that's incorrect. If we look at this one here, then this goes down 4, and then if we go across, let's count carefully, 1, 2, 3, 4, 5, 6, 7, 8. So notice, how do I go from A to this one? Well, I times both sides by 2. So they have to be in the same proportion. So that's the phrase I'm going to write here, in same proportion. That's very important a bit later on. On the grid, we need to enlarge this shape by a scale factor of 3. So the way I tend to do this kind of question, let's start with a random point. Let's start with this point, and I'm going to draw that random point here. Well, this goes along 1, so for scale factor 3, I need to go 3 along, like so. This goes 1 down, so I need to go 3 down, like so. This goes 2 along, so I need to go 6 along, 2 times 3 being 6, so 2, 4, 6. This goes 1 down, so I need to go 3 downwards, like so. I can draw it anywhere on my grid here. This goes 3 along at the bottom, so I need to go 9 along. So 1, 2, 3, 4, 5, 6, 7, 9, and then this is good because this all should join up, and this should be 6 going down, so 2, 4, 6. And notice I'm always double checking this diagram as I'm going along as well. Question 3, I need to fill in the gaps for each pair of similar shapes. So this has got a 6 centimeters here. We don't know what the image is, but we are told the scale factor. So to work out the image, we just do 6 times 3, and this will be equal to 18. This question here, what do we do to 4 to get to 8? That's going to be our scale factor. We multiply by 2. Now this next one we have to be a little bit careful of. So what do we do to 15 to get to 5? Well, we all know to divide by 3, but remember, for a scale factor, we always have to multiply. So instead of saying divide by 3, what we say instead is multiply by a third. Notice that has the same effect. So 15 times a third is equal to 5. So just be careful with shrinking that you've always got a fraction less than 1 as your scale factor. Now question 4 is different to question 2 because we have a point of enlargement. So the way I do this is I take a random point on my shape. So let's take this one here. And I look, what do I need to do to go from our center of enlargement to this point? So I need to go 3 downwards. Now because we have scale factor 3 again, I need to go, instead of 3 downwards, I need to do 3 times 3, which is 9, so I need to go 9 downwards. So 3, 6, and 9. So that point will go right there. Perfect. Now let's take another random point on the shape. So let's use a different color here. Let's take this point on our shape. So in order to get there, we need to go 2 to the right and 2 downwards. So because we're timesing by 3 here, we need to go 6 to the right and 6 downwards. So 2, 4, 6, 2, 4, 6, like so. So this point gets, I have to do it again now, oh no, 4, 6, 2, 4, 6, like so. Okay, so this point gets enlarged to there. Once I've got this, we can actually work out that because this is a scale factor of 3, similar to how we did the previous question, this needs to be 3 downwards. So that gives me my final point. So I'm always double checking here. And so this will be my enlarged triangle. So if I just show you the answers here, you see I get exactly the same triangle like so. I think I'm in line for, I'm just double checking. Oh, yeah, perfect. Right, now we need to enlarge on a grid, so it works in exactly the same way. This time the center of 1, 2, so we go 1 along and 2 upwards. So we're going to enlarge from here. And again, we can do this similarly to how we've done it before. So let's use a different color here. So to go from, let's take this random point, we're going to go 1 to the right and 2 upwards. So we've got a scale factor of 2 here. So we need to go 2 right and 4 upwards. So this point will come to here. Now the kind of lazier approach here is once you've got one of the points, we already know the scale factor. So if this is 1, this needs to be 2. If this goes across 3, this needs to be 6 going across. So 1, 2, 3, 4, 5, 6. And then we can finish off the rest of the rectangle. So if you're happy with this kind of process, you can just take one point and then build up the shape around it as well. That's also a way of working. So you see there, we get exactly the same one. Question 6, we need to work out the unknown lengths and angles in the pair of similar triangles. So we're told they're similar, so in the same proportion. That's important. Notice here we've got 80 and 60. Angles in a triangle add up to 180. So to work out this one here, we need to do 180 minus these added together, which is 140. So that's equal to 40. So in fact, you'll notice that for both of these, they have the same angle, so all 3 angles are the same, which has to be true for a similar triangle. Now we look at corresponding sides. So what do I mean by this? Well, this is 15 and this is 10, and they represent the same part of the shape. So to work out the scale factor, I tend to do big divided by small. So 15 divided by 10, which gives you then 1.5. So this is the important number we're going to use now to work out the missing sides. So let's work out this side first down the bottom. So we take the 12 and then multiply by the scale factor because we're going from small to big. That's going to give us 18. So 18 at the bottom. And then to work out this one, we're doing the opposite process because we're going from big to small. So for this one here, we're going to do 9 divided by 1.5, which is equal to 6. So this will be equal to 6 millimeters. You can see the answers there. This one here, that's a high-level question, particularly looking at negative enlargement. So looking at scale factor -2. So let me show you how this works. The center is right in the origin here, so 0, 0. So the way this works with a square, this is going to make our life easier. So notice to go from A to our center of enlargement, we go 1 along and 1 downwards. So with this kind of process, instead of going outwards, we go inwards. So we're going to go through the point and out the other side. Because we've got a scale factor of 2, we want to go 2 to the left and 2 down, giving us this point here. So this is our image point. Now, because we've got a square, so it goes 2 by 2 by 2, etc., we know each side needs to be 4. So we can literally just put this in now. So 1, 2, 3, 4, and then 4 across here. And you get this kind of rotation effect when you do a negative scale factor, negative enlargements with a negative scale factor. If you want to learn more about that, then you look into matrices, which is on the IB course for high-level applications. We go into this in a lot more detail as well. But it has this kind of going through the point effect and then coming out the other side. Okay, and you can see all the answers there, so you can see how it lines up. They've given the actual image points. It doesn't say that in the mark scheme you need to do this, but you may want to do that just so you know which point is which. Notice the B point comes in the points. This is 1 along and 3 down. So we need to go 2 along and 6 down, which is why this point is our B image. Just to go through that in a bit more detail. Okay, have a look at the very first page of answers. And pause the video, of course, and then you can look at the second page as well. Okay, and on to ratio and proportion. So again, another important topic, and you're going to see a little bit of algebra in here as well. So the cost of buying 3 cups of coffee is £4.50. Complete the table to show the cost of buying different numbers of cups of coffee. Well, if 3 cups of coffee cost £4.50, then 1 cup will be £4.50 divided by 3, which is equal to £1.50. So what we can do here is literally just times £1.50 by 6, by 8, etc. to work out how much it costs. Another way of doing it is, what do we do to 3 to get to 6? Well, times by 2. So we just have to times this by 2 as well. So a couple of different methods you can do here. 4.5 times 2, that's going to give me 9 here. What do I do to 9 to get to 18? Well, times 2. So I can do the same at the top as well. So 6 times 2 is equal to 12. With 8, because you can times by 4/3, that does work. But we could also add on 2 cups of coffee, which is going to cost £3. So 9 plus 3 will equal 12. So using a combination of multiplying up, but also using the idea of 1 cup costing £1.50 and using that for the further calculation. Question 2, we need to tick the graphs that show a direct proportion relationship. So if it's in direct proportion, it needs to be going as a straight line going upwards and going through the origin. So with that in mind, this is going to be direct proportion. This here goes through the origin, also direct proportion as well. Notice this one here is not direct proportion because we do not start at 0, 0. Question 3, so 5 numbers are in the ratio 1 to 2 to 3 to 4 to 5. And the sum of those numbers is 90. Work out the range of numbers. So essentially this is a dividing by a given ratio question. So I tend to do this in 3 easy steps. Number 1, we add the parts of the ratio together. So we add 1 plus 2 plus 3 plus 4 plus 5 plus 6 all together, and that gives us 6, 10, 15, no 6. Just 1 plus 2 plus 3 plus 4 plus 5. That gives us 15. Number 2, we're going to take that 90 and divide by that magic number 15 we just worked out before. So that's going to give us 6. So I'm going to put that in little clouds because we're going to use that later. Now for this question, we only need to work out the range of the numbers. Now the range, remember, is the largest minus smallest. So with this question in mind, all I need to do is work out what this part of the ratio is and this part of the ratio. So we need to times each of those numbers by 6. So 1 times 6 is 6, and then 6 times 5 is 30. We could work out the middle numbers, so 12, 18, 24, but not necessary for the question. And so the range will then be just the 30 minus 6, biggest minus smallest, and that leads to our answer of 24. Perfect. Now question 4 is a little bit sneaky here. So it takes 2 workers 6 hours to paint a school hall. How long would it take 4 workers to paint the same hall? So remember, that's going to speed up the process. Essentially what we're saying here is if we've got 2 workers and 6, and then we have 4 workers, what will this missing number be? Well, this is going to work inversely. So notice 6 times 2 gives you 12. So we want 2 numbers that multiply to give us 12, so 4 times something, and so the missing number there is going to be 3. Gives 3 hours work. Now the assumption we made, which leads on to the next question, is that each worker, there's a couple of assumptions we've made, but each worker works at the same rate. And also, as you add extra workers, they don't get in the way of each other. So that's kind of linked to this reason as well. So this one's an inverse proportion because as you add workers, there are less time it takes to actually do the painting of the school hall. So that's a little sneaky inverse proportion question. On to question 5. So Dora and Eva, Dora's back again, share some grapes in the ratio 2 to 5. Eva gets 12 more grapes than Dora, and how many do they share altogether? Well, the way I tend to do this, let's have a look at the ratio 2 to 5. The gap at the moment between those two numbers is 3, but we want the gap to be 12. So what do you multiply 3 by to get to 12? Well, we need to multiply by 4 to get the gap of 12 that we want. So we need to do the same on both sides, so it stays in the same ratio. So 2 times 4 is equal to 8. 5 times 4 is equal to 20. And notice this is in the same ratio, but there is a gap of 12 in between them. Now that's not our final answer because we need to work out how many grapes did they share, so the total number of grapes, and that's we need to add together the 8 and the 20. So Dora's 8 and Eva's 20, giving us the answer of 28, like so. Question 6, so which is better value for money? A 400 milliliter can of lemonade for 60p, cool, that's good old days, or a 2.5 litre bottle of lemonade, £3.60. Right, so the first thing to notice here is the units are different, so let's convert it all into the same units. Now there are 1,000 millilitres in a litre. That's a fact you need to know off by heart. So we can convert this to 0.4 litres. This also can be converted into money, so into pounds and not just pence. That's the first thing to do. I think the approach that I would take here, again there's more approaches you can take, is convert both into 10 litres. So I'm going to work out what 10 litres will cost for the first one. So that's number 1. So to go from 0.4 to 10, I need to multiply by 25. So we need to do the same to both sides. Multiply by 25. We'll work that out on the calculator in a moment. And this one we need to multiply by 4. Okay, so 10 litres. And if we multiply this by 4, 4 times 3 is 12. £14 and 40 pence. So we're now going to check whether the can, when we multiply it up, is more than or less than £14.40. So let's go and do that now. So all we're going to do is type in 0.6 times 25 and we get 15. That's definitely more. So this is going to be equal to £15. This is less. So therefore the bottle is going to be the best value for money. Very similar to a question we looked at before, so do check out the other sections of this video. Question 7, the higher level question. So T is 40% of U, V is half of T. Write the ratio T to U to V in its simplest form. Where V is a half of T and T is 40% of U, then that stands to reason that V is 20% of U. Because if T is 40% and V is half of T, so it's going to be half of 40%, which is 20%. So V is 20% of U. So if we write everything in terms of U, if U is our sort of base value, so to speak, our one in the middle, then T is 40% of it, which is 0.4, and then V, which is half of T, is half of that value, which is 0.2. Now it's not in its simplest form at this point, so we need to make sure all the numbers are integers, and the way we can do that is actually times everything by 5. You could do it by 10 and then simplify. So if we do this, 0.4 times 5 is equal to 2, 1 times 5 is 5, 0.2 times 5 is equal to 1. So we get our final ratio here of 2 to 5 to 1. Okay, you can check the answers, so you can have a look through how White Rose Maths have written their answers and how they've awarded the marks as well, and then the last page here too. So it's an important topic. Make sure you've really mastered this as you go on to the next section. Okay, let's look at some probabilities. So number 1, a bag contains 3 blue and 3 green and 2 red marbles, just like in the diagram. A marble is selected at random. What's the probability that the marble is green? So we've got 3 greens, that's going to be our numerator, out of the total amount of marbles that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So our fraction will be 3 out of 8. 3 green out of 8 in total. What's the probability that the marble is not blue? Well, how many do we have that are not blue? Well, the green, so 1, 2, 3, plus the 2 reds, so that makes 5. So we get our fraction of 5 not blue out of 8 in total. So make sure you just read the question. If it says blue or not blue, make sure you put down the correct fraction. Now question 2, the probability of the spinner landing on an even number is 3 out of 8. The probability of the spinner landing on a prime number is 1/2. Now before I even start the question, because the spinner is out of 8, I'm going to convert my half to 4 out of 8. That's going to help me work out what to put in. And now I just need to complete the spinner. Now so far we've got 2 and 3 that are the prime numbers only. So 2, 3, and 5 as well. So we have 2, 3, and 5 that are prime. So we need one more prime number, and we also need 3 even numbers. So we've got 1, 2. So we need a prime that is even to start with. So let's pop in a 2 here. So that means now we've got 1, 2, 3 even numbers out of 8. So now I need to fill this in with an odd number that's not prime. So 15, I think, will do the trick on that one. Let's just double check. So landing on the prime number is a half. So 2, 2, 3, 5. That's fine. And probability of landing on even is 3 out of 8, 1, 2, 3. Yeah, I'm happy with that. Again, there are plenty of other answers for that question. Now, Nija records how many times a die lands on 4 after a different number of rolls. Now, complete the table. One thing I teach my students, particularly at year 11 and beyond, is look for patterns in the question. So even if I don't know what relative frequency means, of course I know what it means, but even if I didn't know, notice I've got a 3 and a 10 here, and the answer is 0.3. So how do these numbers link? Well, if I take 3 and divide it by 10, then I'll get to 0.3. So the question's really asking me to just do 5 divided by 20, 10 divided by 5, and so on. Now, if we do 5 divided by 20, well, that's the same as 1 over 4, and that's 0.25. It'd be interesting to see if they accept non-decimal answers. This one's going to be 10 over 50, which is the same as a fifth, which is the same as 0.2. Okay, you can use your calculator to check these. And our last one is 24 over 100. Well, that's just going to be 0.24, like so. And which relative frequency, so which of these decimals, gives me the best estimate of the probability of the die landing on 4? Well, we want the large sample size. So that's always literally the first thing I'm always going to write down in the relative frequency question, iGCSE, Year 9 or otherwise. Large sample size. Which has the largest sample size? Well, this one here. So the 0.24 is going to be the most accurate. Question 4. So the table shows the probabilities of a bias spinner landing on each outcome. Okay, and the spinner is spun 400 times. Estimate how many times it will land on yellow. So the first thing we need to do here is work out the probability of it being on yellow. Remember, all probabilities, if we add all these up, are going to equal 1. So we add what we have so far. So 0.3 plus 0.2 is 0.5. Plus 0.15 is 0.65. And if I take that away from a whole one, that's equal to 0.35. So that's the first thing that we need to do to work out probability. And now to work out the estimate of yellow, I tend to write EY here. That's equal to the probability, 0.35, multiplied by the number of times that I spin it. Okay, let's go to the calculator, work that out. So get 0.35 times 400, and that's equal to 140. So we just pop that in, 140 times. Again, we'll write in 140 times, indicate we know what the question is talking about. Now onto a classic two-way table question. So this is very, very common, GCSE, iGCSE, in lots of different courses. We need to complete it first of all. So we just keep filling in gaps that make sense. So 250 here plus 120, so the total here is 370. Total here is 770. Let's try to do the most easy calculations possible. This is 490. Difference between 240 and 400, that's going to be 160, and then that will be 280. And now I'm going to double check here. So 490 plus 280, yeah, that gives me 770. So always double check and work in a different direction to make sure you got all the answers. One person is selected at random. What's the probability that they are under 40? So out of the 770 people, that's my denominator, how many are under 40? Well, that's going to be 490. Generally in these questions, I don't expect you to simplify the fractions. Just keep that in mind. So 490 over 770. Then the next question we have to read carefully. A person aged under 40 is selected at random. So out of these 490 people, so that's going to be our denominator, how many are male? So out of this column, so we're just focusing on this column now. We're not looking at anything else. How many are male? Well, that is 240, like so. There is a complicated formula you can use, but just do it this way it kind of makes intuitive sense. So A and B are independent events. Probability of A is 0.4, so probability of B is 1/4. Find the probability of A and B. So as soon as I see and in probability terms, I'm always thinking multiply. So we need to do the probability of A multiply the probability of B. Now we can do this because they're independent events. So 0.4 is the same as 4 over 10 multiplied by 1/4. We can do some cross cancelling, that's helpful. And then we're left with just 1 over 10. Perfect. Okay, so usually you have to be a bit careful because you'd have to minus the intersection, but because they're independent, there is no intersection. Number 7, so Esther gets on the bus every Monday and Thursday. If she catches the bus, the probability she will be late to school is 0.15. Complete the probability tree diagram. So tree diagram is a really important topic to understand. The first thing to understand is that pairs of branches add up to 1. So if this is 0.15, then this has to be 0.85. Both have to add up to 1. And notice there's no change whether it's on a Monday or a Thursday, so the probabilities stay the same. So this is 0.85, this is 0.15, this is 0.85, this is 0.15. Conditional probability, that does come up, but at this point we just want to make sure we're happy with tree diagrams. Now, find the probability that Esther is late for school on exactly, very, very important word, one of the 2 days. Not both, has to be exactly one. So we want to work out the probability of late and not late, and then the probability of not late or on time, and then late. So we want to take this branch, if I put it down there, and let's use a different color here. I also want to use this branch as well, because these are the only combinations where you're late exactly once. Now, how do we actually work this out? Let's set this up nicely. So when we're going along the branches, we multiply. So 0.85 times 0.15, and then we're adding on the second combination, which is 0.15 times 0.85. Notice I'm writing everything very clearly for the examiner. Let's go to the calculator and work it out. Right, so let's open those brackets. 0.85 times 0.15 plus, and then the other way around, obviously it'd be the same calculation. Multiplication being commutative, it's a nice word I like to use, at least at year 9 level. All right, and then we get our final answer of 0.255. So we pop that in, 0.255, like so. Right, so you can check through the answers, so you can have a look at all different questions that we have looked at. If you've got any questions about the probability, you want me to do some more advanced videos, maybe a separate video, then please do let me know. And do check out the video in front of you. So this is me going through a very typical Year 9 Maths end of year exam. So this goes through a lot of the topics I've covered in this video. But if you really want to test out whether you're ready for an actual Year 9 exam, then check out the video right in front of you.